Awesome. Okay, rolling offsets. Here we go. So rolling offsets, as you already know, this is not new information on this screen. As you already know, we learned how 45 offsets can be calculated by knowing a rise or a run or a travel. We could use Pythagorean theorem. We could use our 1.414 if we have a run or a rise to calculate the travel. And that really is not new information. We should know how to do that quite easily, and I would say that you do. Any questions? Perfect. So here are the parts of the rolling offset. And first off, there's the rise, and the rise is how much it rises, and the roll, as you can see, the roll is how much it spreads across that isometric box, the offset itself, and the run and the travel. So the roll is kind of close to that. So this is the terminology that we will use to describe any one of those lines in a rolling offset. And here's the thing, if we need more terminology, well, here it is, right? So remember, when you can see, I'm circling the 45 degree here. Does everybody see that? Somebody? Anybody? That 45 degree?
Yeah.
Now, there is a deal about 45s. Now, sometimes they won't give you this angle. They'll just put a question mark in there. And if there's a question mark there instead of an angle, there's a different way to solve. So anytime you have a figure or an image to refer to, please do that. Make sure you see what is on the image. Okay, let's go to the next. So now, when calculating these rolling offsets, they want you to visualize this isometric box, as you can see here. Now, when we have an iso box and we're talking about a rolling offset, and if you're drawing isometrics on a piece of paper and it's a rolling offset, you should be putting this box in there so it indicates that, so it doesn't just look like a 45, okay? You should draw this little box around, you know, your roll, okay? So the roll means that the pipe enters the bottom over here, and it runs up and it exits out the top, but on the opposite side of the box. So we have this thing called a roll. So you would roll your 45s here and here to gain that area. So this is going diagonally across that box. Is there anything you want to ask or add to this screen? Pretty straightforward so far. Now, when 45s, here's the deal, okay? So when 45s are used, if that says 45s, the length of the run is equal to that of the offset. So the run and offset are equal. Does that make sense? We know that already. We know that already. So when you're using 45s, these two things are equal. So if you're writing notes on this, if it's a 45-degree rolling offset, the run and the roll, or excuse me, the run and the offset are equal. Okay. Now, there's a couple of on-the-job methods that they use to calculate some of these rolling offsets. If it's a very small rolling offset, you can actually use a steel square or a square where you measure out the roll, you measure out the rise, and then you can get your offset. So, and then measure between the 2 points to get the offset measurement, and then multiply by 1.414 to calculate the travel. So this is to get the offset itself. So once you have the offset, guess what? We times that by 1.414 to get the travel. Okay. Man, you know, it's hard to draw with a mouse. I don't even know if you guys tried before, but it is a little hard. So that's one way of doing it. Another way of doing this on the job for very large offsets. Now, this is more of a steam fighter kind of deal or steam fitter kind of deal, is if you're calculating these larger offsets, is the direct layout. And using the square to ensure the rise and the roll form a 90-degree angle. You remember that little rule, that 3, 4, 5 rule? You can use that to ensure you're working with a perfect right angle. So that's one way of doing it. And then you can measure and mark out the lengths of the rise and the roll and measure between these two, and then simply multiply by our magic number. Let me scroll down right into 1.414, and we can find the travel length. And this is used for bigger pipe, for bigger jobs. That way we're measuring probably 2-3 times to ensure we have the right, and we cut once, and we only do one cut. And let me tell you, I know my particular boss always liked one cut, one time, because, you know, if I cut a pipe more than once, it usually ends up being too short. I don't know why, but it just happens. So there you go. Now let's see. Okay, so look at, we know this, if 45-degree elbows are not used, this says not, so if they're not used, and you know the rise and the roll, you can calculate the offset by using Pythagorean theorem. So look, we have a roll, we have a rise. Roll is 6, the rise is 8. So you simply take the rise squared plus the roll squared is equal to the offset. So the offset is the square root of them together, and then the travel is getting the offset, and you times it by 1.414. Now you're going to have some questions in the assignment, and it'll talk about the relationship between the offset and the roll, and if you have 45s and if you don't have 45s. So some of this terminology is going to come back, and you'll have to kind of regurgitate a little bit in the assignment that I've posted. Okay, so I'm going to clear my drawings here. Do you have any questions so far? We're doing all right? Okay. So now that we have that new information, let's have a look at this one here. So we have a rise and we have a roll, don't we? So if we go 6 squared plus 8 squared, that's got to equal my offset, but offset. Okay, but we have to square root that, right? So if we do that operation right there, 6 squared plus 8 squared and then shift square root, we should get what the offset is. So let's see if we can do that. So 6 squared plus 8 squared is equal to 100 is my offset. And now I could take that 100, which is equal to my offset, and I could times that by 1.414, and that should equal my trowel. And let me see if I can, hey, there we go. Look at that.
And also asking for the run as well.
It's not asking for the run because this particular one, when you're doing this, let me just, when I'm multiplying by 1.414, this means that these are 45s, right? And if I had a 45, the run is equal to the offset. So the run is going to be 10.
Okay.
Because the offset is 10. You can see how it says run slash offset here?
Yeah.
Because these are 45s. I don't want to go too quick. I don't want to leave anybody behind here. I need like a beeper or a bell to tell me when to advance. Okay, I'm going to click on the next screen. We're going to do some more calculations here. And there we go. Oh, here we go. Similar, almost. As you can see, I have 433 as a rise and 635 as a roll, right? This particular pipe, you see it comes in here and it exits here on the other side. So it's a cross. So we want to get the travel. So when we are only given two variables, we're going to use that method. So it's 433 squared plus 635 squared is equal to my offset slash run. And then we multiply our offset by 1.414 to get the travel. And I think if I click on this next one, it'll come up. There we are. So the run or the offset are equal. So that's why it has run offset in this one, because these are 45-degree fittings. And I didn't give you that information, but there it is. It says 45. And then it starts talking about a fitting allowance. Don't worry about the fitting allowance right now. I am just trying to get the travel. And you can see down on the bottom here.
Yeah, can you move that black line, please?
Trying here, I don't even know. Ooh.
Thank you.
There we go. So the travel is this number, which is the run or the offset times 1.414, and we get to the travel. And then it talked about these 45s having a fitting allowance of 22. So we minused off 2 of them to get 1043. Not too bad, huh? Okay. I know it's 10 to the hour, so we probably want to take a break. So I'm going to just stop sharing right there. Let's take a 10-minute break. Please go get something to drink. Not try try to stay away from the alcohol right now. I know it's, it's after 12, but still, that's still considered day drinking. So stay away from the alcohol, go get some water or whatever, some Tang, whatever it is you got in your fridge. Walk around a little bit, come back here at 1 o'clock. Resume recording. And then I will reshare my screen to where we left off. So we left off here where now we know the formula. Like, let me just write this formula down. I'm going to write it down right here. Hang on a second. I'm going to write this formula down. This is when we have 45. So anytime you're working with 45-degree fittings, you use this formula to find the offset. And then you have to multiply that by 1.414 to get the travel. So this is the formula we're going to use to solve the rolling offset travel when we use 45s. Okay, so that's one formula we're going to use for 45s. Clear? You may want to write that formula down somewhere. Okay, for 45-degree rolling offsets, use this formula and then multiply your offset or run by 1.414 to get the travel. Okay, now, here's the deal. When the roll, the rise, and the run are all known, so when you have 3 variables given to you, okay, we can use this modified version, this modified Pythagorean theorem to get the travel. So these are going to be listed. They're going to give you run equals something. They're going to get the rise equals something, and the roll equal something. And then we square the run, add the square of the rise, add the square of the roll, and then square root it all, and that's going to equal our travel. So there it is. There's the second formula that we are going to use, and this is for when the angle is not known. So this angle we don't know. Now, on some big jobs, some pipe fitting jobs, they just have to fit up some of these pipe. And they're not all 45s. They're not all 22.5s. So they're unknown angles, and they have to manufacture these fittings, and they do that by using miters. And they could cut pipe into pieces and create their own fittings for this stuff. And that's what they do in the field sometimes on these big jobs, big pipe. When some things don't quite line up, they have to fit it up, so to speak. And that's why they're called pipe fitters. I mean, there's other reasons why they're called pipe fitters, but I don't want to get into that because that's not very kind. So there's the second formula right there. Okay, so remember that formula, write that down somewhere. This is for unknown angles. Okay, unknown. All right, I'm going to move on here. Now, I want you to solve for this travel. Now, I did say earlier, this is for unknown angles. It is also for any angle that is not a 45. So we're going to use that formula that I just told you about the rise, the roll, and the run, all squared and square rooted to get the travel. So we're going to go 11 squared plus 10 squared plus 12 squared. And once you do that, shift square root, that is your travel, and that is all there is to it. So this, as long as this is not a 45, use this formula. Now I'm going to clear that drawing. I know it was quick, but this is going to make sense when I click the button here. And there it is. So the angle is not 45. We're going to use the run, the rise, and the roll. All three variables will be given to you. They will all be there on the paper at any given time if the angle is unknown. If you only get two, then it's almost likely we're using 45s. So you could make that assumption, okay? And I'll go over another one with you or so. Does that make any sense? Do we have any questions to this point? Is there any questions? Okay, well, here's another one. So here's the thing. I don't know what my angle is here. I'm unsure. So what we can do is we could take our roll. You see the roll up here? The roll is 610. So I'm going to go 610 squared. And I'm going to take my rise. You see the rise right here, which is 1080. And I'm going to plus 1080 or 10, sorry, 610 squared plus 1080 squared. And I'm going to just do this to see if that is equal to the run. If that's equal to the run, then I can assume that this is 45s. So I'm going to do this math on my calculator here. 610 squared plus 1080 squared, shift square root. That didn't work out. 610 squared plus 1080 squared equals shift square root. Guess what? That equals 1240. So what that tells me is that offset right here is 1240. Then for sure, these are 45s. Okay, if these two are the same, then I know that these are 45s we are using. And let me just click forward here. I'll put all the math on there. There you go. So when all the dimensions are given, you can check to find the length of the offset and the run if they're equal by just taking the roll and the rise and finding out that number. And it says down here that it's 1240. Therefore, 45s are being used. And then to calculate the travel, we simply take that number, the offset for the run, and multiply it by 1.414, and that would equal the travel.
So if there's no angle given, basically you have to find out what the angle is first, and then you know what to do from there.
That's correct. So we can figure that out. So this is just a way of figuring it out to see if my run here, that's 1240, here I'm going to annotate again, this 1240, if this is equal to the offset, then I know I'm working with 45s. So we just calculated this to find the offset or the run. Remember, if this didn't come out to the same as this run here, then we would had to then add the run squared to this and square root it all to get the travel, right? So that's for an unknown. So yeah. I find this actually quite hard because I don't get to see you guys when I'm doing this. My whole screen is filled with this PowerPoint and I don't see any of you guys. That doesn't mean anything though. But, okay, let's give you another example. Okay. Let's see if I can do this. Let me see if I can share this screen. Okay, can you see my screen with the little rolling offset in there?
Yes.
Yeah.
Yeah.
Okay, so I'm going to give you some numbers. We're going to do a couple of quick. Let's stop this. And then I've got to open this up. Okay, so here we go. We're working with 45s here. As you can see, it says there's a 45-degree angle right there. So we're working with 45s. I'm going to give you some numbers. I'm going to say your rise is equal to 95 centimeters. I'm going to say the roll is equal to 50 centimeters. I want you to solve for the travel. So take a minute and solve for that travel. And when you have that travel solved, I lost the group here. Can't see you anymore. Why don't you shout out your answer?
151 centimeters.
That doesn't sound correct. Well, wait, actually, no, you're right. That does sound correct.
Yeah, I
Yeah,
got
151.7. So what
Yeah.
you did was you took 95 squared and you added 50 squared and you square rooted it. And that came out to 107.35. And then you multiplied that by 1.414. And then my travel equaled 151.7 centimeters. Yes, easy peasy, lemon squeezy. Not too bad, huh? Okay, let's do one more example on this. Oh, look at this one. Okay. Do we know the angle here? No, it's not there. So I'm going to give you some measurements here. So I'm going to tell you that the rise is equal to 4 feet 3 inches. I'm going to say the roll is equal to 3 feet 6 inches. And I'm going to say the run is equal to 5 feet 4 inches. I want my answer in feet, inches, and to the nearest 1/16 of an inch. So take a couple minutes and do this question.
Hey Doug, question 12 on your assignment is wrong.
Oh dear. You wanna send me an email?
No, I thought I'd just tell you over this to save you the emails this time.
Just straight up tell me? Oh, man. Okay, thanks for that. Number 12, eh?
Number 12.
What can I say? Really nothing, but that's okay.
No, you're only human.
After all. See that commercial, they use that song, We're Only Human, and it's a toilet paper commercial?
I don't think I've seen it.
Anyway, we all use the facilities, I suppose. Okay, I will put my answer in here. So that is 4.25 squared. That's 4 foot 3 inches. And I'm going to plus 3.5 squared. That's 6 inches. And I'm going to add 5.333 squared. That's 4 inches. And that equals 18.0625. And add 12.25 plus 28.444. And I add all those together, that's going to be 58.75. And if I square root that, that is going to equal 7.665 feet. And 0.665 feet times 12 inches per foot. That is so close to 7 foot 8 inches. I'm going to call that good. Is that what you got? I hope.
I
You
got
didn't close.
Yep.
7/8.
Yeah, there you go. 7 foot 8 inches. And there's the formula to get the travel. When your angle is unknown, or it's not a 45. If the angle is not a 45, you most always will be given 3 variables. So you're always going to be given 3 variables. And then you use this formula with the 3 variables. Okay. Is that clear, easy, concise? Can I remove that now or no? Let me go on. We'll do one more before I get you to do the assignment. Okay. So the next one, I want to know, okay, we're going to do 45s, and it's a rolling offset. So you have a run. Let's
Hey,
put a
Doug,
run.
Yeah, Mo just texted me and said his internet went down and he's just trying to fix it. So I'm just giving you a heads up. Sorry to cut you off there.
No, that's good. Thank you. I appreciate that. Actually, I don't mind the interruptions at all. Please do so. Okay, at any time. Thank you for that. The run on this one, let's call the run 2,000 millimeters. Let's do the rise of 1.2 meters. Let's do a roll of 1,600 millimeters. So What is my travel?
Two 2,828 millimeters.
Right. Now, the easiest thing here, now here's the thing about this one. Because this is 45s, right? It's just simply the run is equal to the offset, right? They're equal. So I take the run or the offset and simply times that by 1.414. That's my travel. So we just simply take 2,000 times by 1.414. That equals 28 millimeters. So in this particular scenario, I gave you a lot of information. But here's the thing, if you knew this was 45s here, knowing the terminology will get you there easier. If you know the formula.
So when I did this, I got that they weren't equal. I got the it being 2332.
No, the offset is equal to the rise squared plus the roll squared is equal to the offset.
Oh, okay. I was doing the run. Thanks.
Yes, yes. So that terminology is coming back then, but thank you for that. We just have to get that right. So if you're doing that to ensure to ensure that, that's going to be 1,200. That's going to be 1,200 mils plus 1,600 mils squared, shift square root. And if you do that, that is equal to 2,000 mils. So the run and the offset are equal, because that is for the offset. Okay, so a little bit different terminology than some of our other equal spread and unequal spread stuff, but still using the same numbers. We're mashing together Pythagorean theorem and the 1.414 to solve for our rolling offsets. Cool. So Mo is down for the count, which is whatever. It's fine. Happens. Happens to the best of us. I haven't actually had it happen to me yet, but I know it's happened to other instructors. I've seen it. I've heard about it. So they've dropped out. And sometimes our signal gets pretty weak. You know, if we're streaming videos and stuff, yeah. Or if everything in your house is relying on Wi-Fi instead of hardwired, it's harder. It's harder. Okay, so that wasn't too bad. Is everybody okay with that? Now, this is the time where you can have this opportunity, Sylvie, go in there and do the assignment. I think there's 20 questions for assignment number 9.
Oh, I will. Don't worry.
I know you will. I know. So there's only 20 questions to do, and it is due Friday morning, this next assignment. Also Friday morning, there is a quick quiz that I'm added to the schedule. So there's a Friday morning quiz, and then we will be going over mechanical advantage.
Is the quiz going to be on like offsets pretty much?
The quiz is on some offsets in there, and some volumes and capacities. So because of the last quiz with the volumes and the capacity of that, I decided to add a couple of easy questions in there on volumes and capacity.
Okay, cool.
Okay, and some offset stuff, some easy offset stuff.
Hey Doug,
Yes, sir.
before the final, are you gonna like release like a review maybe for us that we can do or something like that, just to get prepared for it? Or are you gonna do a review by any chance?
I will
Questions?
do a review with you.
All right.
I'm pretty sure I will.
Okay, sounds good.
And yeah,
If we're done the quiz, are we done for the day?
you know what? We are done for the day. If you want to stay in the room and hang out while you do your homework and while I check question number 12, apparently, and to see if I'm right or I'm not right. Hey,
You're not right,
Mo.
Doug. You're wrong.
I'm wrong. I'm wrong.
You're wrong on that one.
Well, welcome back, Mo. We got your message. Thank you for that.
No, sorry, just loving internet nowadays. Everyone's on their computer at home.
Yeah, I understand. I understand completely. I do. I get it. It's crazy out there. We just finished off with another example of that, and I'll show you that example. I'll pull it up here. But for all intents and purposes, everybody, we are finished this particular lecture on rolling offsets. And now it's your turn to do the assignment on D2L. And if you want to eject from here, you may do so. But first and foremost, use your time wisely. If I let you go a little bit early out of class, I expect you to be working on the assignment, you know, not running to the golf course like I'm doing. But no, just kidding. I'm going to be around. I got a meeting at 3 o'clock anyway, so I have to stay here. So please use your time wisely as we let you go to do that assignment to get some work done in math class. Yeah? Cool? Okay.
All right,
Thank
Doug, have a
you,
good day.
Hey,
everybody.
thanks, Doug.
Yes, have a good day.
You too. Bye.
Mo, this is the screen, the last thing I did with the group. So there was the numbers that I gave to everybody. And then I wanted them to solve for the travel. But these were 45s in here. And so it came out quite easily where if we do know what the run is in 45s, we just simply times it by 1.414 to give me the travel. So we proved that the offset is equal to the run. So it proves that it was 45. So I think that's all what you missed there.
Okay.
Okay.